welcome back to Well, That's Interesting, what else do you do at a research facility edition. Today is episode 245. Putting vampire bats on treadmills is weird. Their metabolism is weirder. And this is the longest running laboratory experiment so far. My friends, if you're a long-time listener of the show, then you know when we're not talking about a hole in space, a person, or the deep ocean, we're probably talking about a fascinating animal. Yet, in the 5 years of this show, vampire bats have only come up as a side fun fact just to help explain a rare behavior exhibited by a completely different animal. And hold on, if you're already finding yourself saying, whoa, wait, vampire bats? Fascinating? Oh, come on. More like gross. If you're saying that, I'm going to need you to hold on to that thought. We will get to it. First, that side fun fact I was talking about. I've only mentioned these toothy bundles once, and it was back in April, during episode 232, when exposed to currency, African gray parrots chose to share, and another study that reveals the amazing lives of honeybees. Oh my, we learned quite a bit that day, like African greys aren't capitalists at heart, and they're more than happy to give currency away, which during an experiment was metal rings. They were willing to give these rings to another bird so that bird in need could exchange them for a treat. This is altruism, or selfless giving. And if you stop and think about it, for an animal in the wild, it could be a dangerous choice. But vampire bats, they are on the list of creatures that give a helping hand. Or rather, a regurgitated meal. Here's the fun fact. As reported by the National Aquarium's website, aqua.org, vampire bats must eat every 70 hours to avoid starvation. But nonetheless, it's a common sight to see one bat puke up small amounts of their own food into the mouths of roost mates that did not feed. And I can see the look on your face from here. It's a mix of, oh, that's so nice of them. And it's a realization that I'm talking about one bat essentially puking blood into the mouth of another. And yes, I agree, visually, that is a lot. But you can thank me, because I had the restraint not to share an image of this on the socials. Your imagination is enough. Speaking of meals, in the first half of the show, we're going to talk about a first-of-its-kind experiment that reveals these bats' extraordinary metabolism and why this makes them oh so fascinating. Vampire bats are the only mammals that engage in hematophagy, which is a fancy way of saying they don't eat anything, per se. They feed exclusively on blood. And if that sounds strange to you, you're right. Just listen with whom vampire bats share hematophagy company with. Mosquitoes, fleas, black flies, tsetse flies, lampreys, which is a kind of fish, leeches, and ticks. These are creatures we frail humans do our best to avoid because they are infamous pests. So, the million-dollar question here is, how in the holy hell does a mammal, a flying mammal, survive on blood alone? Well, if you said, to figure this out, we're going to have to start by catching about 24 wild vampire bats from Belize, and then we're going to have to put them on a treadmill to measure their carbon dioxide for certain amino acids. If you said that, you are right once more. We will meet the curious team from the University of Toronto Scarborough, who did all of that to answer a question no one asked, but we are so glad that they did. We will watch bats on a treadmill. We will be amazed at how good they are at running. Yeah. We will get into the nitty-gritty of the experiment, and of course, we will learn how bats transform blood into a viable energy source, and just how efficiently they do it. Oh, I hope you're hungry. Then after the break, clear your schedule. The University of Queensland is currently live streaming the longest running laboratory experiment in the world so far. And yes, you can watch it now. But what's even more shocking is that this experiment has been going on for so damn long. Two of its custodians died while waiting for results. We will travel back in time nearly a century to when a simple demonstration began. It started with getting together some pitch, which is the name for any number of viscous, highly viscous, or slow-moving liquids which appear solid, and sticking it in a sealed glass funnel. That funnel was turned upside down so the pitch had a chance to escape, and then everyone basically waited, and waited, and waited for any of it to drip out. We will get into the nitty-gritty details of this experiment, which is still going strong. We will learn why in the holy hell we are waiting for bits of pitch, and the literal reason as to why it takes so goddamn long for it to move. Short answer, physics. In the meantime, grab a comfy chair. And hi, I'm Jill Chacha. And if this is your first time listening, welcome to the flock, my well-intentioned business goose. To begin, I'm going to ask you to grab a warm cup of hot cocoa, a cozy blanket, and to plop down into your favorite relaxing position because I'm going to tell you way more than you ever wanted to know about the lives and feeding behavior of vampire bats. Specifically, the common vampire bat with the adorable Latin name of Desmodus rotundus. If you drop your own Desmodus and pick up your phone to head on over to today's post on the old socials, you're going to see a photo of one who clearly wasn't ready to get their picture taken, least of all with a flash. But you can't fault the photographer for using it. According to G.S. Wilkinson's book, The Social Organization of the Common Vampire Bat 2, Mating Systems, Genetic Structure, and Relatedness, you know the one, these little chonks can be found throughout Mexico, Central to South America, and prefer nearly pitch-black spaces, like caves, mines, old wells, hollow trees, and rarely used human structures. Despite the seemingly depressed surroundings, however, vampire bats live it up in colonies that could easily be adapted into a complex TV series on Netflix. Roosting sites are made of female groups and their offspring, with only a few adult breeding males around, simply called the resident males. And that could be the name of the show until you realize on occasion a separate group of males, aptly known as the non-resident males, can be found here as well, and the number of these guys fluctuates as the ambient temperature lowers. So, as the weather gets colder, roosting sites warm up with more bodies, and there's no drama to be had whatsoever with the resident males keeping a sharp eye on the transient non-resident males, all while kicking out a number of 9-month-old males, which sounds a wee bit too young for us humans, but that's actually when bats sexually mature. Speaking of bodies, these unconventionally cute cuties are bite-sized. No pun intended. From head to tail, they're only 2.5 to 3.5 inches in length. And that may be small, but to take off, they still need a wingspan of about 8 inches or so to get to their destination, which, other than their roosting site, is a hunting site. And boy howdy, we need to talk about how they hunt. My friends, prepare yourself for this one. Although every other bat has almost lost the ability to maneuver on land, vampire bats can walk, hop, jump, and even run by using their incredibly strong forelimbs or arms to propel themselves forward. And they can do this with marvelous dexterity and swiftness. Put a pin in this. In the meantime, here is fucking why they evolved to not only fly, but to crawl along the goddamn ground. Quote, they don't want to flutter down and drop right on the back of a cow. Instead, they land a few feet away, silently approach the cow's leg, and make a tiny painless incision with the cow none the wiser. End quote, said Kenneth Welch, a biologist at the University of Toronto Scarborough, who studies vampires and other animals with specialized diets. And he said this in an interview with Jack Temizia of the New York Times. So, like a fucking well-equipped Marine, vampire bats used what's called the inferior colliculus, nailed it, a part of the brain that processes sound. And it's so accurate, it can detect the distinct breathing patterns of a sleeping animal. Once the bat has determined a cow, horse, or pig is dormant, it strategically lands several yards from their target and then army crawls their way over to a limb, all shrouded by darkness. Using what's called thermoception, they identify a warm spot on the skin, but before they take a bite, I shit you not, they apply anticoagulants to prevent blood from clotting. And they do this with a series of licks. Yeah, their saliva contains a number of these anticoagulants, but the primary one is the oh-so-on-the-nose name of Draculin. And it's evolved to be so successful. The unique properties of Draculin and other components of vampire bat saliva have actually inspired research into their potential use in treating blood clots and strokes in humans. Studies published in the oh-so-on-the-nose medical journal called Stroke, Journal of the American Heart Association, report of a genetically engineered drug that's based on this stuff, and it actually increases blood flow in stroke patients. So please, focus on this, and not how the upper incisors of a vampire bat are basically surgeon-grade knives, so sharp that when they enter the skin, it's barely felt. Yeah, ignore that. But here's something you can tell your friends over brunch. These little nibblers have 38 teeth, but no molars. And that's because they don't need to chew solid food. So all they have are pointy ones. Okay, maybe that was actually a little too intense for brunch, but it doesn't compare. That intensity does not compare to the bonds that form back at the roosting site. So this Netflix series is about to ramp up a notch. Remember at the top of the show I mentioned altruism and how vampire bats share/regurgitate their liquid dinners with those who fail to sip up their own? Well, you might be wondering if this is only between related bats of a colony. If you thought that, you're not the only one to do so. As reported by Jason Goldman of Scientific American, Ohio State University behavioral ecologist Gerald G. Carter and his team ran an experiment with 30 wild vampire bats from 2 different unrelated colonies in Panama. They then introduced pairs of unfamiliar bats to each other in a lab. Check this out. Quote, "Some of the animals quickly began grooming the stranger they were partnered with, just a little bit. In some pairs, grooming eventually gave way to food sharing. The latter, or the food sharing, was relatively rare, and it was always preceded by grooming, a much lower cost investment. The amount of grooming rose sharply in the days just before the first instance of food sharing, and then it plateaued afterwards. This study makes the point that reciprocity is not some cold, calculated tit for tat, but ultimately rests on trust, and that is built up over time. It's part of an emotional, close relationship that is also speculated for primates. Grooming among primates may do the same thing as in bats. Prepare relationships for occasions when mutual assistance is truly needed," said Emory University primatologist Franz de Waal, who was not involved in the paper. Carter agreed, noting that even after the bats were returned to the wild, many maintained the relationships they initially formed in captivity. End quote. Building trust, maintaining it, not only with family, but the family you choose. This is an award-winning series. We can call it Blood Ties. Oh, it basically writes itself. Speaking of blood. What a segue. How in the hell do these bats live off of it exclusively? I mean, most mammals like you and me, we get the bulk of our energy from delicious fats and stored sugars that I want right now. Anyway, let's find out, shall we? Join me, will you, back with Kenneth Welch, a biologist at the University of Toronto Scarborough, who was just quoted a moment ago about how vampire bats use stealth when it comes to hunting. The old Welch isn't a stranger when it comes to studying creatures with bizarre metabolisms. 20 years ago, his work focused on hummingbirds and their use of sugar and nectar. Recently, his focus turned to another flying animal, the common vampire bat, and he got to thinking. To fuel their own flight between meals, tsetse flies oxidize the amino acid proline from blood meals, so maybe vampire bats also break down amino acids for energy. So, to test this hypothesis, he teamed up with colleague Julia Rossi, currently a postdoctoral researcher at McMaster University in Ontario, and they took a trip south to Belize, which is to the east of Mexico's Yucatan. There, they had the sweatiest time of their lives, collecting 24 wild vampire bats, and when they returned to the lab, the following took place. Please, Drop whatever wild animal you're holding right now and pick up your phone. Head on over to today's post at the old socials and swipe until you see the adorable photo of a bat wrapped in a white blankie being fed with a tiny syringe. I'll give you a sec. Yeah, I mean, that syringe is filled with cow's blood from a local slaughterhouse, but look how cute the little fucker is. Oh. And you should also know for the experiment that the blood was laced with something extra. High concentrations of 2 amino acids, glycine and leucine. And what the fuck are these? I gave these a search, don't worry. Long story short, glycine is the simplest amino acid with a single hydrogen atom, but it's enough to help maintain tissue, hormone function, and acts as an inhibitory neurotransmitter, particularly in the brainstem and spinal cord. So she tiny but mighty. And leucine is a key building block for proteins. It's essential for muscle growth and repair. These things are in your mammalian body right the fuck now, just doing their work, silently. And they were also added to this here cow blood. Now, as to why, it's kind of ingenious. If these amino acids are metabolized, the researchers can pick up their isotope signatures in the bat's exhales. Yeah, from their carbon dioxide. The question is, though, how the hell do you get wild bats to breathe for you? Answer: you get them on an enclosed treadmill. Stop working out yourself and pick up your phone, swipe past the photo of the bat in the blankie, and you're going to see one running on all fours and moving on a conveyor belt. Now, if you'd like to see this in full action, simply Google bats on treadmills, and behold, they have no problem whatsoever walking, hopping, and running. It is fucking wild, and I mean it. Thanks to this study, we now know these 3-inch-long pointies can move at nearly 100 feet per minute, and they can move non-stop for 90 minutes straight. That is horrifying and impressive. So what the fuck is fueling this gladiator-level ability? Drumroll, please. Thank you in the back. From the New York Times, quote, "As the bats sprinted, the team collected samples of their breath to measure the intake of oxygen and the expulsion of carbon dioxide. By analyzing the CO2, the exhaled CO2, the scientists could pinpoint traces of the amino acids from the blood the bats had ingested just before running. The researchers discovered that the breakdown of both glycine and leucine from the treated blood samples was responsible for as much as 60% of the bats' total energy production during their runs. This illustrated that vampire bats can turn amino acids into usable energy almost instantly." End quote. Yeah, my equally swift business goose. Just like flies, these mammals can turn blood into energy-rich gold 10 minutes after their intake, thanks to being able to metabolize the amino acids in it. To put how radical this is into context even further, the only other known time a mammal resorts to metabolizing amino acids for survival is when bears hibernate, or when emperor penguins forego food for months in the winter. Quote, "What's different here is that this seems to be what this animal is going to do all year round, every day when it feeds, and that it's making use of the protein in that blood meal that it ingested just minutes before. That's really what separates these animals from most of the rest of us." End quote, said the Welsh to Matthew Sparks of newscientist.com. So, is there any drawback to an all-blood diet? Of course there is. Bats develop relationships and maintain them so well because they have largely lost the ability to store and process other fuel sources. A healthy person can typically survive 1 to 2 months without food, but a vampire bat? 48 hours to 70 hours tops. And they need a lot of blood to live too. A typical female vampire bat weighs 40 grams, or 1.4 ounces, but she needs to consume over 20 grams to keep going, which is basically half her body weight. It's like always living on 1%. As for the 24 bats Welch and the gang captured, well, I'm happy to say that they were re-released into the wild, and I have a feeling they're sticking together. After the break, vampire bats may be swift on their hands and feet, but we are switching gears and taking our sweet-ass time in the next experiment. Get comfortable and stay tuned.
This episode is brought to you by Nordstrom. Summer's almost out and fall's calling. Luckily, Nordstrom has everything you need for the season ahead, all under $100. Discover new arrivals from your favorite brands like Mango, Princess Polly, Wave, Free People, BDG, and more. Whether you're planning a last-minute getaway, heading back to class, or refreshing your office looks, you'll find the latest trends and beauty must-haves without breaking your budget. It's easy, too, with free shipping, free returns, and in-store order pickup. Shop today, in stores, and at Nordstrom.com.
If you work as a manufacturing facilities engineer, installing a new piece of equipment can be as complex as the machinery itself. From prep work to alignment and testing, it's your team's job to put it all together. That's why it's good to have Grainger on your side. With industrial-grade products and next-day delivery, Grainger helps ensure you have everything you need close at hand through every step of the installation. Call 1-800-GRAINGER, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
And we're back. We are so back. And my friends, I'm going to ask you to pull up a reclining chair and to fluff a pillow because we're about to dive into an award-winning experiment where not much happens. And that's the point. Please, join me, will you, on the wild continent of Australia during the roaring 20s, and brace yourself, as we're about to watch Thomas Parnell, the University of Queensland's first professor of physics, warm up a very misleading substance called pitch. But first things first, if you imagine Australia and point to the very middle of the East Coast, you'll be tickling the city of Brisbane and the university itself. The year is 1927, and we're standing alongside good old Parnell in Building 7. In his hand is pitch. And you're probably like, what the hell is that? But don't worry, I've got you. Pitch, aka bitumen, is an immensely viscous form of petroleum. And if you're from the States, we here call that asphalt or tar. And guess what? According to the university's website, at room temperature, pitch feels solid, even brittle, and can easily be shattered with a hammer. But, in fact, at room temperature, the substance is actually fluid. Yeah, old Parnell is holding a fluid. And if you think that's crazy, just wait. It's about to be heated up, so its apparent solid form relaxes into the classic version of tar we know and love, thick goo. But as to how thick she really is, well, that's what this experiment is all about. The first clue that pitch is unlike any other substance on Earth dropped shortly after it was heated. Placed into a sealed funnel, it took 3 years for it to settle into its new shape and to completely cool. The glorious day finally came in 1930 when old Parnell cut the narrow end of the funnel to release the hounds, if you will. But as expected, absolutely nothing happened. The pitch didn't budge. There it sat, still, year after year after year, until, appropriately enough, like a gift from old St. Nick, the very first drop fell in December of 1938. Now, I can't imagine the fucking joy felt by Parnell and the other physics professors, not to mention the confusion of everyone else as to why this was happening, because finally, calculations of the pitch's viscosity could begin. So take note, everyone. It took 8.1 years for one drop to be had under room temperature conditions. So with this, if you find yourself asking, oh, Christ, does this mean we have to wait at least another 8 years for another drop? If you ask that, you are absolutely right. 8.2 years later, in February 1947, the glorious second drop was recorded, and this would actually be the last time old Parnell would see any results. He passed away a year later in September 1948. At this time, his department had some serious questions to answer, like what happens to consciousness, and what do we do with all his shit, including the pitch experiment? That question, just as with pitch itself, is truly misleading. For you see, anyone who inherits this project will certainly die before witnessing a handful of drops. A handful, if they're lucky. I mean, Who wants to confront their own mortality and be in charge of an experiment that might take centuries? My friends, for 14 goddamn years, there the pitch sat, gathering dust with no official caretaker to lay claim. But during that time, a miraculous third drop fell early, as though calling out, "Hey bitches, don't forget about me." Luckily, it was recorded in April 1954, 7 years after the last. If you drop whatever bullshit experiment you're performing right now and pick up your phone to tap on today's post, if you swipe past all those bloody adorable bats, you're going to see the hero we need right now. That is John Mainstone, and he's absolutely proud and beaming and standing next to the famous pitch. John answered the call, probably with a statement like, "Fuck all y'all bitches, especially death, I got this." John adopted the pitch experiment in 1961 and was rewarded in the worst way possible. And when I say worst, I mean the funniest. The 4th, 5th, and 6th drop fell under his guardianship, each spaced out like clockwork every 8 years, but he still physically missed witnessing any of it. That is amazing, but my favorite drop is number 7. As so wonderfully told by the wiki, quote, "The 7th drop fell approximately 4:44 p.m. on July 3rd, 1988, while the experiment was on display at Brisbane's World Expo 88. However, apparently no one witnessed the drop fall itself. Mainstone had stepped out to get a drink at the moment it occurred." End quote. Now, that is so infuriating. But don't worry. We can add to it. Sometime after the 7th drop, after it fell in 1988, air conditioning was added to the location where the pitch was being held, which means during summer, the room actually got cooler. Yeah, and I think you can see where this is going. With lower temperatures, liquids like pitch solidify just a little bit, so it takes additional time for them to warm back up and loosen. So yes, my friends, this means the average drop rate has increased from every 8 years or so to 10 to 13 years. And we know this because the next drop didn't fall until November of 2000, 12 years later. Thanks to modern technology, a webcam was installed with the goal of capturing that very moment, but thanks to modern technology, technical problems prevented that drop from being seen. If you don't laugh, you'll cry. But seriously, that webcam is still going strong, or at least it's been fixed, and you can take part in this experiment. If you head on over to the10thwatch.com, that's the10thwatch.com, and never move to get yourself a drink, you can be the second human to witness a drop. The second, that's right. When our hero, John Mainstone, died on August 13th, 2013, age 78, following a stroke, custodianship was passed to Andrew White. A year later, in April 2014, it happened. The 9th drop was in the process of dripping, and Andrew was in the fucking room as it was happening. But there was a problem. Of course there was. For you see, under the funnel was a beaker, and in that beaker were the 8 other drops. They had collected and layered so much so that the 9th drop, as it elongated and dangled, made it clear that it had no more room to drop. This drop would become a bridge that fused the remaining pitch to the drops, thus preventing any more drops from dripping. Does that make sense? Good. So, to prevent such a catastrophe, Professor White decided to replace the beaker. And as he lifted up the jar containing the pitch, the 9th drop just snapped away. So not only was White the first to see this happen in person, the pitch was in his fucking hands at the same time too. That is wild. And that is why the webcam is called the 10th Watch. Number 10 has yet to fall. And according to the clickety-clacks, it's going to be soon. Very soon, like any day now. It's been 11 years. And speaking of clickety-clacks, let's talk viscosity. Thanks to 9 drops, and nearly a century later, and considering all the fluxing temperatures, this particular sample of pitch is 100 billion times more viscous than water. At this rate, Professor Andrew White, the current custodian, he could live for like another 100 years, and the experiment would still be in full swing. That funnel is not running out of pitch anytime soon. And thank you for listening, rating, subscribing, telling your friends about vampire bats. Well, yeah, I mean, at any time, it's always the right time to tell your friends about vampire bats and how they run. Just mimic it. Just like pretend, just get on the floor and just go for it. Just abandon yourself to, okay. And then tell them about the longest running experiment. It's going to be a great conversation. And a drawn out thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you're going to love the other podcasts in this family. And please, stay interesting.